Here's our product examination project done by Yvonne, Jonathan, Kenny, and Anthony. For this project, we were able to disassemble the Nikon Coolpix 8.1 megapixel into parts to then be examined for their manufacturing process. First, we will be examining the battery holder and door. In examining these parts, we noticed that the battery holder's complex shape, as well as ejector pin markings on both parts, has led us to conclude that these parts were made through injection molding. Next, we will examine the back panel of the camera. The back panel has a complex shape shown to provide for the different features of the camera. In addition, ejector pins are present to verify that this was also manufactured by injection molding. Alternatively, this part could have been manufactured by thermoforming. The trade-off of thermoforming would be that the process would be less expensive and have a shorter lead time, but would degrade the details on the component.
Now we will examine the circuit board. The through-hole components were likely to have been wave soldered, while small mounted components were refloat soldered. This circuit board mainly has surface mounted components, however the red arrow indicates the pin connector was a through-hole. Hand soldering was eliminated as a possible manufacturing process due to how difficult and time-consuming the process would be, making mass production impossible. The next component to examine is the front circuit case. The complexity of this component as well as the injector pin markings shown by the red arrows led us to conclude that this part was manufactured through injection molding. Next component we have is the front case of the camera. It is made of aluminum and we believe that it was manufactured using metal stamping process. A clue that led us to this conclusion is the uniform thickness of the plate, which also indicates that it was stamped from a flat sheet.
As seen by the ejector pin marks, injection molding was the process used to make these gears. In this process, plastic pellets are melted and injected into the empty part of the mold. A possible alternative process that could have been used for this part is casting due to the simplicity of the design. The interior top casing was also likely to be made from injection molding. An alternative process for this part that could have been used is thermoforming. This process may have been chosen over casting since it has a higher production rate and overall low tooling cost. Most of the parts of the camera were likely to be made from injection molding, including the internal hinge. 3D printing could have also been used to make this part. However, this process was not likely to be used since the part would not be able to be mass produced. The internal support of the camera lays right on top of the circuit board. The process that was likely used to create this part is progressive die stamping. In progressive die stamping, material is fed through a feeder and goes through multiple operations, such as piercing and trimming, until the part reaches its final design. An alternative process for this part could be roll forming in addition to transfer die stamping.